John Gilroy here. Today, we're going to learn about how to manage emerging technology in a virtual world. Hit the music, Manny.
Welcome to the Federal Tech Podcast, where industry leaders share insights on innovation with a focus on reducing cost and improving security for federal technology. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcasts.
Welcome to the Federal Tech Podcast, the podcast that links you to federal technology leaders. My name is John Gilroy, and I will be your moderator. Our guest today is Dan McGuan. He is Senior Director, Technical Sales at Rancher Government Solutions, and we are recording this at the AWS Public Sector event in lovely downtown Washington, D.C. Dan, a lot of people outside, aren't there?
Yes, there are. Thank you very much for having me, John. It's great to see you.
Thousands and thousands of people all over the place. Now, this is about AWS. I came down here to spend 2 days to listen about AWS. But Dan wants to talk about open source.
Yes. I mean, that's kind of at the core of emerging technology, right? And from where I sit, and the majority of my career of having been in the open source world, we've watched the federal government, lean away from adopting open source 15 years ago to like, ooh, I need a special permission to do this, to leaning in, being like, you have to give me a reason as to why you're not using open source. And it's been an incredible thing to watch and a wonderful wave to ride.
Let's paint the picture of this discussion. Rancher Government Solutions offers a way to manage something called containers in an effective way. And I'm going to paint the picture from 20 years, then you can fill in the details. Years and years ago, this thing called virtualization came about, where they could virtualize operating systems and made people much, much more productive. It took this virtualization concept and it amplified it. It took it into producing small containers for code that could be managed and improve efficiencies in the cloud. And this has taken off to a point where people are challenged with just managing the number of containers they have. So in steps Kubernetes, which is a way to manage containers, but has some limitations. So that's the cue to you. Yep. Rancher Government Solutions, how can you help my government listeners manage all these crazy containers everywhere?
Yep, absolutely. I would like to take a step back just for a moment, kind of explain why it matters that Kubernetes is an important component of containerization. Containers as a function of the operating system have been around for a long time in the context of like LXC or Docker even. Kubernetes was a project that was open sourced by Google in either 2013 or 2014.
Don't say Google at an AWS conference.
Fair enough. But the fact of the matter is that the entire world and every cloud provider, AWS included, is built a managed service of Kubernetes for their users to be able to abstract away the administrivia associated with operating Kubernetes at scale. What we here at Rancher Government have done, is kind of our claim to fame, is we worked with the Department of Defense to create a completely vendor-agnostic distribution of Kubernetes that is designed for the use of the federal government. So meeting STIG, the first Kubernetes distribution to have a STIG, we've got various SE Linux enforcement underneath the hood, and all the other integrations and checklists that you would have to be able to apply to the kube layer in order to operate Kubernetes in your environment in the first place. So we make it extremely easy to run a hyper-secure Kubernetes stack. Be that as it may, managing those containers themselves, we are Kubernetes agnostic. Use mine, use AKS, use EKS, especially if you're here coming from the Amazon side, right? Everyone's on EKS. So many of our customers are on EKS. We sit above the Kubernetes layer and provide a level of observability and orchestration and operational security to those individual container images. And in doing so, we permit the end user to blend across their various environments, or secure and stabilize those environments, whether they're on-premise and on Amazon cloud, or if they have a persistent Kubernetes service on Amazon cloud and are bursting to EKS, or in many cases doing it in the opposite way, using EKS for their CI/CD pipeline and then having their production stack be wholly owned in an air gap. We facilitate that exact type of use case, and it's something that we are watching the federal government become more and more in need of as the container surface area is expanding so rapidly.
I'll toss a case study at you, and I read this morning. morning, and I was amazed at it. There are ships in the Navy, and a lot of them are becoming floating data centers. Okay, so data centers consume a lot of electricity. Surprise, surprise. And so one way to manage that electricity is, guess what? Through Rancher Government Services.
That's right. You got it.
Who would have thought that's the answer? So Dan here gives us a very technical answer, very methodical thought through, but the bottom line is, hey, we're running out of space on this ship, and can you help us? And we go, as a matter of fact, we can.
Right?
I know.
Well, the interesting part here, too, is that the degree to which you can replace equipment in these smaller locations. Right? I'm not saying that naval ships, naval vessels are small, but it's that if I've got physical equipment like rack-mounted stuff, I might have to theoretically cut a hole in the side of the boat to get replacement equipment onto or off of that ship, right? So we've watched these smaller form factor devices that would be more considered like kind of forward operating location or kind of edgy, but not really edgy, but they're running ARM, right? And ARM processors are extremely low wattage and extremely high density in terms of CPU. So the notion that you can run our Kubernetes stack on ARM ARM equipment and then man portable, like walk that stuff onto a ship or walk that stuff, into a forward operating location or literally drop it from a parachute from an airplane to, warfighters in the theater and have a fully featured, completely stabilized and secure, designed for government, open source first Kubernetes environment running your warfighting applications anywhere on the planet, because you've got this really small form factor compute from these ARM processors, but providing the power that's necessary to actually have a positive warfighter outcome is huge benefit.
But I've heard it's as small as 4 inches. And what I've seen is there are ground stations that control satellites that are taking advantage of this.
That's correct.
Because we want something small and fast, and we don't want you to ship a server in. We don't want a Dell server. We want something, put it in a FedEx box.
Yeah. Well, our CTO,
and they do.
Right? We do. It's like our CTO, Brandon, tells a joke all the time. It's like you can't really throw a guy out of the back of a plane with a 610 strapped to his back, right? Yeah. But if you're here this week, stop by our booth. We actually have a Packstar 453 device, which is basically the size of a pretty large book, and it's got an NVIDIA GPU in it, and we are actively connected to the AWS backbone here inside the data center, doing things from that single node to IoT Greengrass and provisioning things inside of their big shipping container device that Amazon takes out. I guess it's the Snowball Edge or the very large device. So we're literally right next to that environment with the tiny little single node of Kubernetes actively provisioning IoT Greengrass on the backbone of the network here at AWS Summit.
Well, I admit, I'm stuck in x86. I'm stuck in AMD. That's me. That's kind of like, well, we've always had a 6-cylinder Chevy. But now, wait a minute. Maybe we have a twist on this. Maybe NVIDIA's got some insight. Maybe there's a new way to process this where we can reduce power consumption. And that's going to get the attention of the DoD. Especially on ship. Yeah,
well, density is always the problem, especially because you've got workloads that are, you're used to scaling up. And in a traditional virtualization sense, right? And I think that itself is becoming quite a problem for the Department of Defense as legacy virtualization vendors and new pricing models and things of that nature have really started to put the screws to a lot of the government customers that have defaulted to legacy virtualization. And where the end customer requires a powerful and performant application in a not so I want to say like enterprise environment, like I don't really have 3-phase power and all the ping and pipe that I need. Like I'm literally going to have something the size of a brick running very mission critical applications wherever in the world this application needs to go. We find ourselves kind of at the intersection of the end user trying to do that with a scale up traditional virtualization workload, and then at the intersection of microservices and containerized applications being faster to develop and requiring less compute footprint. So there's this interesting collision going on from where I sit, which is we want to transform, but we know it's complicated, and we want to get there, meeting my legacy virtualization provider wants to charge me 3x for the thing that I already have, and that can't help me transform. And I see that is really kind of forcing the hand of a lot of organizations that I speak to about, all right, we're going to have to make the investment in transformation anyway. Right? We're going to have to figure out how to get emerging capability and development capabilities into our workflow faster, because we can't afford to keep the lights on at this price point. And we've got a solution for that with our Harvester technology.
Well, I want to talk about Harvester, I want to talk about NuVector, and I want to talk about Carbide, but we're midway through this interview. So people are listening to this, and there's snow on the ground. So, Dan, where can they get more information about these products?
So I encourage everybody to hit www.ranchergovernment.com. We just rolled out a brand new branded website, and it's got a hamburger menu on the top left, and it'll illustrate to you all the depths and greatness of our products. You can hit our white papers, and you can start pulling down things as simple as one-pagers. If you're on the executive end, you just need some talking points. And if you're a technician, we've got all types of documentation available on the front end of the website at no cost. Just come, grab some stuff, take a look around, hit the upstream. You can hit our Docker Hub. I think it's dockerhub.io/Rancher Government, and you can grab all the software that we ship. We are, like I said, a 100% open source organization, and we would love for you to reach out to us and let us know how we can help.
Yeah, I'm sure that the NVIDIA folks and the GPU folks they focus in one area, and other people may be looking at NuVector and Harvester. So how do you differentiate those two offerings?
How to differentiate Harvester from NuVector. Mm-hmm. So we'll start with Harvester is effectively Kubernetes itself, right? It's a capability called KubeVirt. And KubeVirt it allows the end user to take hardware and hyper-converge physical equipment together, right? So it's basically running Kubernetes on metal. But what you really have that brings the special sauce is that it allows you to co-locate containers and virtual machines on the same substrate. So KubeVirt becomes the compute abstraction layer, becomes the hypervisor, as it were. But because it's Kubernetes, it's playing host to your containers on the same equipment and the same infrastructure directly adjacent to your virtual machines. So as we watch our customers and people we speak to about this capability today becoming extremely trepidatious about what it means to continue down the path of their legacy virtualization investment, we are observing that the reality is to take the traditional virtualized workloads and place them onto a capability like Harvester. Because then I've got my microservices and my containerized applications all adjacent to those virtual machines on the exact same compute substrate, and you can reuse the equipment that you already have. So as a guy who came out of the HPC world, my previous employer was doing lots of high-performance computing. We found that emerging technology projects were using leftover HPC equipment because it was already paid for and it was already dead on the vine.
I would too, yeah.
Right? Why wouldn't you? It's free equipment, right? And we would find that the most interesting use cases that became part of the zeitgeist of the federal computing realities, right, were happening in these places where you had leftover equipment, an extremely difficult relationship with a software vendor, or a pricing increase, or a dead on the vine piece of equipment, and combine those things together with open source technology, and you could get some pretty remarkable things done. And this feels very similar to that. Like if anybody who's listening remembers OpenStack, it feels very very similar to the OpenStack reality, where it's like we've got leftover equipment. We've got a capability, but we've got class workloads that we can't get onto a cloud because it's like the 2013, 14, 15 timeline.
Yeah.
So we're just going to build our own cloud. We're going to air gap this massive infrastructure and run OpenStack on this high side network or whatever it is, right? And then once Amazon got IL5 and the various other security classifications in their government enclaves, everybody just went whole hog over there, right? So that equipment becomes available again. This feels very similar to me because you've got a legacy vendor with a legacy capability that wants to bolt on the container pieces, right, and the Kubernetes pieces, and the workflow styles, and the continuous integration, continuous delivery, the methodologies, the digital transformation methodologies. I'm going to bolt them on something that you're buying as a product, when in reality it's really more of a perspective shift. It's more of a philosophy shift.
Yeah.
Right? We're providing a capability to say we're going to continue our investment in our virtual machines, because our virtual machines, that's the thing that we care about, right, is the workload that lives inside this VM, right? But we do need to make an investment that will allow us to transition to a containerized world, because the pace of development is faster, and the scale horizontally as opposed to scale vertically reality is better for resource consumption, much as you said earlier, John. So there's just a lot of realities that we're bringing to play where your government end user who is getting sticker shock for their renewal for their legacy technology can have not just an easy button to not have that cost exposure, but at the same time bring with it a profound new capability that will get them to where they want to go in the transformed way even faster.
Well, it's almost, I teach my students in digital transition, is that you shut up and listen, and then you respond to what your customer's problems are.
Yeah.
It's like, okay, Dan, you shut up and listen. Oh, here's the problem. Bang, bang. Okay, well, how about if we make this transition easier than it would be? All of a sudden, it makes more sense. Now, it could be the curse of success is that containers are being so popular, so many of them, that the malicious actors are going, oh, great, new kid in town. Hey, come over here, little Danny. Come on, here. Hey, let me hold your wallet for you.
Yeah, exactly. As he literally touches my wallet on the table.
And so then we have security, and guess what? Hi, we're Rancher. We can help with that. So there's a security offering. I think that's what NuVector is.
That is correct. So SUSE bought a California company called NuVector, which is layer 7 Kubernetes security. And like a lot of things, or basically everything in our portfolio from a management perspective, it doesn't care what Kubernetes you're running, right? The same way our Linux manager doesn't care what Linux you're running, right? Like we just don't care. Like we want to make open source so open that like if you want to buy the infrastructure components from us, that's totally cool. But we can manage all your existing choice. We want to enable choice and enable choice to persist for the end user, and that's super critical philosophically to open source, right? And that's why I love working here. But you're right. There's a security perspective. The adoption of containers and the way container networking kind of works inside of Kubernetes is that you get this very large east-west attack surface, right? And NuVector is a capability that deploys to any Kubernetes stack via Helm chart. And it actually has onboard intelligence that will watch the way these containers are behaving in a standard operating environment, and then take note of any behavior that is occurring between the container pods as deviant behavior and automatically start turning stuff off. It is perpetually scanning the container images from the registry all the way down to the images that are running in production, and comparing them.
That's a wide range. I'm just saying.
Oh yeah,
Think of that.
I mean, it's very, very large. I mean, I can't name the customer. By name here, right? But we're talking like hundreds and hundreds of physical nodes of Kubernetes.
Right. This is not easy.
It's not easy, but NuVector makes it really easy, right? Because one, it's got the observation aspect, but as far as layer 7 is concerned, it can actively start disabling things. Like if you get another log4j vulnerability, another log4shell vulnerability, the idea that everything is exposed, you realize you're exposed, and you've got to go in and turn things off, or have a Sev1 incident, get 50 people inside the SOC and try to figure out how much risk has happened, right? Are they in this particular environment? Are they in our storage? Can they exfil? Are they exfilling? Have they done so, right? The RCA is happening, while the risk has already been encountered. NuVector prevents that from happening entirely because it won't allow you to run a container that's got a log4j or log4shell vulnerability in it. It will not permit you to perform certain functions inside the container. And because it's wired up to your RBAC, inside your network anyway, it's relatively easy to take advantage of all the security that you've already applied to the infrastructure layer and then get the end users that last mile to layer 7 and let NuVector's intelligence say, nope, you're blocked, depermitted. Nope, you can't run that because it's not cool. These two noisy neighbor containers starting to talk to each other, don't like that. Pull them out of service, right? It is not a reactive tool. It is a proactive tool, and there really is nothing like it in the container security marketplace. It is a fantastic capability for anyone running containers.
Well, speaking of fantastic, Tommy Lee Jones once said that phrase, well, I don't care. Remember that movie? I didn't kill my wife. I don't care. And he said it pretty much effectively. Yeah, I was reading about NuVector, and I was going, oh, what? It can go from code to the end? I mean, it really is just, it's an amazing technology. But I think what happens is when technology matures over time, like in the early days of Doc, no one even dreamt of anything like this. But now it is 5, 7, 8, 10 years in, all of a sudden people, and all of a sudden they're communicating to each other. Really? Yeah. Well, we didn't design that. Now, wait a minute. You can, but we didn't design that. And so the solution comes in when it's needed. And this seems to be the solution because, the technicians talk about east and west and north and south and all kinds of communication, what's fair is not fair, and within the pods. And I'm sure Dan could bore you to tears what a pod is and what a pod isn't. But
I prefer not to.
Yeah. But the idea is that you have a virtual environment that makes you more effective, and it can be managed well so the malicious actors don't get in, because they're going after denial of service attacks. Again, it's back to the future.
Yeah.
DDoS, yes, back to the future. Going after APIs, yes.
Yeah.
Hey, let's go after Kubernetes. Why, sure. We'll have that after lunch. They don't. Tommy Lee Jones, they don't care.
They don't care.
They're going after it.
The threat actors certainly don't care. And the mechanism by which this capability is integrated into Kubernetes environment, like I said, it's a Helm chart, right? So you can be an EKS customer and not using Rancher management, my over-the-top container management tool. But you can use NuVector inside of that Kubernetes environment, right? The same way you can do it from any other Kubernetes vendor. Whether you can be running OpenShift as a managed service, you can be running it on your premise, you can be running Tanzu on your premise, you can be running Tanzu as a managed service. It does not care. NuVector is completely agnostic when it comes to the kube layer. And I think that because we are so concerned with that high side, like the layer 6, layer 7, networking and the exposure of the potential exposure of all those containers, right? It's like I heard a story of a government customer who somebody went to Docker Hub and just grabbed a random container image.
Oh, that was bad.
And then ran it in an on-premise container environment.
It's called a John Gilroy move.
It might be so. Well, this individual didn't realize that this particular container which they pulled from just a random repo in Docker Hub was mining cryptocurrency.
That's a John Gilroy move, making that mistake.
In a government data center.
Lose your job.
So, again, this was in that example, right? NuVector would scan that container image that individual was attempting to put it on the network and be like, no, you cannot. Das ist verboten, right? Like, never going to happen. And that's just an example of an action. But like all of the networking realities at the back end there, things are just packets are moving back and forth, east and west across the entire surface area. That is an attack surface in and of itself. We are looking at the individual packets themselves and analyzing those packets. And if something sketchy is going on, we are actively turning things off, depermitting behaviors, isolating individual networks or even pods inside those networks, creating honeypots, and then functionally fixing attempting to remediate to the degree that it is possible at the tools level. We are out there and actively enforcing. So it's a very different look at how to do container security, and it's super cool.
When you went through your little story about that guy pulling the code and it was easy and they could do it, and then it brings up the topic of S-bombs. Yet, Rancher Government Service, they're in there. They have a product called Carbide. Yes, okay, so let's say you're very methodical and you're Dan the careful guy and he very carefully gets the code and puts it. That means there still could be problems, and so there's a product you folks have that can work with S-bombs inside a container. Okay, yep. S-bomb in and of itself is a complex thought, making sure supply chain's safe, but then putting within a container and managing that?
Yeah. So Carbide is more, to the degree that it's a product, I kind of characterize it as a series of security enrichments.
Beyond NuVector.
Beyond NuVector,
wow.
Yeah. So what Carbide does is it takes the core infrastructure software stack of Rancher, right? So that's RKE2, which is the government-grade Kubernetes stack. That's completely open-sourced. Right. And then you've got the Rancher Manager, which was the first multi-cluster management capability to have a STIG, right? That we take both of those capabilities directly from the upstream source, and we pull them into a security pipeline that was built for us by ChainGuard. And what we're doing is we're using Trivy and Tecton and a handful of other very serious capabilities to further inspect the upstream software without making any changes to it at all. Right? I want to make this clear. This is not an open core style play. Right? We're taking open source software, we are inspecting it even further, and then we are providing cryptographic signatures for every single component of the Kubernetes stack and of the Kubernetes management layer. And we make those available to our end users, complete with software bills of material and attestations from us directly downrange to the end user. So if you have a somewhat non-permissive AO and you need to build an ATO'd Kubernetes environment for any type of workload, or you want to build a CI/CD pipeline, or you want to mirror image a Platform One in your enterprise or anything of that nature, this is a super awesome series of enhancements because you're getting all of the attestations, all the cryptographic signatures that are being verified against our private key, by the way, and the software bills of material for the entire software stack. So you're getting this hyper-trusted, hyper-validated series of software components that are, one, open source and emerging and extremely capable, but two, engineered to the spec of government requirement for security. So we're starting down with extremely secure, extremely validated open source software that is really rocking, and then over the top securing it with NuVector, which is coming to Carbide, I believe, this fall.
I was taking notes and I wrote down CICD, and then I missed the next three acronyms. I mean, I think technical types will understand this conversation in detail.
I've also had a lot of coffee this morning.
Yeah. And we introduce this with how to manage emerging technology in a virtual world. So that's the theme of this.
Yep.
And if you want to dig deep, just listen to this podcast, because we're going to go really, really deep and talk about so many topics. I mean, you could get a transcript of this, which I'll provide, and you could just pull out Harvester, study that, then you can just pull out Carbide, then you can pull out NuVector, and just talk about the transitions. And the statement was at the beginning, RK, this is specifically designed for the federal government.
Yeah.
I mean, this is custom. It's a custom suit. What's it called? A bespoke suit?
A bespoke suit,
bespoke.
From Savile Row, right?
Right.
It's from
bespoke.
America, obviously, right? Yeah, from New York City.
But it's responding exactly to the problems that now, if you have a data center in Ashburn, you're concerned about power, but But if you have a data center in Taiwan somewhere, I mean, then you can be very careful about the power consumption. So that's interesting. So back to AWS conference here. So spend a couple days here. Who do you expect to talk to? Do you have any appointments with any interesting people? I mean, where do you think the show's going to head?
Well, you're obviously the most interesting person to talk to.
Don't tell my kids that.
No. I mean, my day is back to back. I mean, just yesterday I was down at AWS HQ2. I did a panel discussion with Harold Smith, who is the co-founder and CEO of Moncton. They do application transformation and like edge type application development. Think like mobile, but kind of on steroids, exclusively for U.S. government. And then Ryan Legg, who's the president of Big Bear AI Defense and Intelligence. And we had a really awesome conversation about digital transformation in government, trends, things that we've seen, basically asking us our opinions about stuff, right? And so I foresee having that as a springboard that's going to influence my conversations this week, because already we've been on the floor for a couple hours this morning, 10,000 people milling about, right? We've got conversations about virtualization. We've got conversations about the CentOS end of life. We have conversations about, there's a lot of conversation about Edge, right? Edge is super hot because of, the DoD trying to take enterprise, use case and workloads out into enterprise quality equipment, right? But take it further afield into exotic locations. I see that as influencing the majority of my conversations over the next couple of days, which is great because it's something I know very well. It's something that we do very well here at RGS. And it's something that I think a lot of organizations have I think everybody's got a CentOS exposure issue, right? I think the majority of the DoD is trying to figure out Edge in various ways. So I think that there's going to be a lot more of what we've already discussed, and I'm really looking forward to getting on the floor and having the fun conversations.
Yeah. Well, Dan, I'm going to end this interview with a quote from a world-famous philosopher, a guy named Ron Burgundy. And he's famously said, CentOS, it's kind of a big deal. I mean, you casually toss that out there. This is a big foundational concept in the industry here, and we can make bad jokes and talk about Harry Potter or whatever we talk about here, but this is a significant issue.
It is, yeah. So at the end of this month, so I mean, it's June right now, right? I don't know when this went up on the internet, right? But at the end of this month, CentOS 7 goes end of life.
Big deal, Ron.
Which is a problem.
Yeah.
It's not an insignificant risk to lots of government users. And then CentOS 8 and CentOS 9 have transitioned to an update delivery model called Stream. And what this has done effectively is break the one-for-one parity that CentOS has with the world's largest enterprise Linux vendor. And again, this kind of harken back to my HPC days. There was a world where all the high-performance computing development that was done on test systems, the test beds were CentOS, and the production systems were in enterprise Linux, and that is no longer possible. And I'm looking at enterprises that have tens of thousands of pieces of physical equipment, on the inside the wall that are running CentOS 8, CentOS 7, and this delivery remodel, this update stream, that this change that's occurred is going to be extremely difficult, if not impossible, for the government customer and the application administrators to keep those applications stable and up to date, because they don't have a function of the update cycle for the dot releases, as it were, for the Linux infrastructure underneath it. And we've got a solution to that problem.
As Ron Burgundy would say, CentOS, video update at 11. Maybe that'll be our next interview. Maybe we'll have Ron Burgundy here.
Hey, that'd be hilarious. I've never met him.
Yeah. You have been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest, Dan McGuan, Senior Director, Technical Sales, Rancher Government Solutions.
Thanks for listening to the Federal Tech Podcast. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.